Come on back. Okay, so let's move on. We did law of sines, and you're excellent at the law of sines, aren't you?
Yeah.
It's like right in your wheelhouse, right? Hey, give me law of sines. I'll give you the answer right away. What if we're given a triangle where you don't have a side and its opposite side? What about triangles where you're given just all three sides? Like, what if this was the side, this was side C over here, and this was side A over here, and this was side B down here? Suppose you're just given three sides. Do you think you could figure out the missing angles without having any angle?
Yes. No.
Let's see what you can do. We'll call this angle C, angle B, and angle A. And since I'm working with these three sides in particular, I like the equation a squared plus b squared is c squared, but that doesn't apply unless you have what kind of triangle?
Right.
A right triangle. And so I'm going to drop this hypotenuse. I'm going to call it h. H is in for height. And then we're going to call this distance here x. What would I call this distance here?
C minus x or b minus x.
B minus x. Everybody okay with that?
Mm-hmm.
So now I'm going to write two expressions using the Pythagorean theorem. And the first expression is going to be b minus x quantity squared plus h squared is equal to c squared. And I'm going to write another expression using the other triangle. I'm going to write x squared plus h squared is equal to a squared. Now, if you can't tell where this is going, the whole idea is I want to write an expression that involves the letters A, B, and C. I don't want my final expression to involve h or to involve x. We've got two equations here. Let's see what we could come up with to kind of remedy the situation. These two equations both have what? H squared. So I could solve for h squared and get rid of it. So I'm going to solve for h squared. H squared is equal to, I have c squared, excuse me, minus the quantity b minus x squared. And then on the right side, I have h squared is equal to a squared minus x squared. Great. If they're both equal to h squared, then they're both equal to each other. And so we have c squared minus the quantity b minus x squared is equal to a squared minus x squared. So I've gotten rid of the h's. That's a good deal for me. I haven't been able to get rid of the x's yet. But let's try. In order to get rid of the x's, I'm going to multiply out this expression. What happens if you multiply out b minus x times b minus x? What is b minus x quantity squared?
B squared minus 2x.
B squared minus 2bx. And then a plus x squared on the end. And notice that it's being subtracted. So I'm going to distribute the subtraction sign to each of those terms. And I get c squared minus b squared. It will then be a plus 2bx. And it will be a minus x squared. And that equals a squared minus x squared. What do you notice?
X squared.
Yeah, the x squareds. You have a minus x squared on each side. Those will reduce. So we got rid of that x. We've only got one x left, don't we? Okay, so we're going to have to be creative about trying to get rid of that x. But right now, I want to point you to this really neat piece that develops here. I have c squared on the left side, and I'm going to take these other two pieces that I underline in blue, and I'm going to move them over to the right side. And as I move them to the right side, notice that on the right side, I already have a squared. And if we take this negative b squared and move it over, then I have positive b squared. And we pause there for a second. What do you have? Yeah, you have the Pythagorean theorem, don't you? I mean, the law of cosines is almost identical to the Pythagorean theorem. It's just you have this one last piece. We have to subtract that over. You have a minus 2bx. Now, finally, what we would like to do is we'd like to get rid of that x. And when you're wondering if you're ever involved in a situation like this, you're like, well, where would we start with getting rid of that x? Locate x in the problem. X is sitting right there, isn't it? Well, what trig function involves those three pieces? Cosine. Namely that the cosine of angle C is equal to the x value divided by the a value. And if I multiply both sides by a, I get a cosine of C is equal to x. So I can take this and plug this in for x. And I finally end up with this nice formula. C squared is a squared plus b squared, basically the Pythagorean theorem, minus 2ab cosine of angle C. And that's the law of cosines. It looks rather bulky or frustrating, but it's really quite nice. Wait till you work it out in a problem. We're going to write it down in three different ways. First of all, c squared is, again, that a squared plus b squared.
Will you go back to slide for like 1 second?
Sure. I had T-bone steak last night with potatoes. Oh, it's so good.
What's on the menu for tonight?
It's conferences, so I kind of got
Oh, yeah.
probably like some meat sticks and cheese sticks.
Trap
Protein
Team
bar.
Burger Basket for me.
Trap Team Burger Basket was good. Good for you. Way to support. Who here's on the Trap Team?
Oh, I'm
All right, we got Shooter. Shooter McGavin.
this year.
Do you know the reference?
Right.
The jokes are right there. What's his name?
Gunner.
Oh my gosh.
Don't even.
Too many times.
Too many times. All right, I'll stay away from it. All right, so it's c squared is a squared plus b squared minus 2, and then the two numbers that go after it are right here. So it's a and b. And then the cosine is always of the angle out front. So suppose I would change this and I would write it as b squared. What would b squared be equal to?
A squared plus C squared.
Good, I got a squared and c squared minus,
2AC.
yep, 2ac, and there's the cosine of angle b. See if you write a squared on your own. Try to write the a squared one out. See if it matches with what I have. Max, do you know what I learned this morning? Your name, Max, is spelled with 2 C's. Did you know that?
No, I
That was pretty cool. I'm sorry, with 2 X's. I said 2 C's. I
Yeah.
was thinking about 2 X's.
so confused.
I thought you were like math.
Yeah.
Like, okay. This is
All right, so if you look at this decision tree piece right here, a couple things I want you to know is that you will have the law of cosines available to you on the test. Okay? So you can see the 3 forms there. You can also see the law of sines. Obviously, you remember the law of sines. You don't need help there. Okay? But that's what you have at your disposal. Okay? So that piece will be there. Today we want to classify different types of triangles from what we did the other day. So we're going to start with these 2 classifications. We have this triangle of ABC. A is 26 degrees, B is 12, and C is 15. A is 26 degrees, B is 12, and C is 15. What kind of triangle do we have? Is this side-side angle, or is this side angle side?
Side angle side.
Side.
Are you confident?
Yes.
Yeah.
Because the angle sits between the two sides. So this is a side angle side scenario. And if you look at your decision tree, it will tell you to just solve by using the law of cosines, and that you can be confident that there is just one solution. So I'm going to go ahead and start using the law of cosines. First, why can't we use the law of sines?
Because it's SAS.
Okay, good. Which means we have an angle, but we don't have its opposite side. So the law of sines requires you have an angle and its opposite side. Every other time you've been given that right away. Now you don't have its opposite side. So we would like to use the law of sines eventually. So in order to do that, I have to solve for the missing side. So are you going to use the c squared equals, the b squared equals, or the a squared equals option? A squared. So I set that up. A squared is equal to, and I'm going to have 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 26. And we'll let you write that down, and it looks really messy. Don't worry, you have the most helpful calculators in the world, because your calculators actually understand the order of operations. That was not the case when I was in school. You had to do each part individually and kind of put it together at the end. So it's very, very helpful to enter this into your calculator. Now that everybody has that, please plug it in directly. So that means 12 squared plus 14 squared, or is it 15 squared, was it? 15. So 15 squared minus 2 times 12 times 15 times the cosine of 26. Just enter it all and press enter. Is that my answer?
No.
No.
What do I have to do?
Square root.
Okay, we'll square root both sides. You guys are smart. You beat me to the punch there. We got 6.74. That is my answer. So I'm going to go over here to A. I have 6.74 equals 6.74. Can I now use the law of sines? Yeah, because you have an opposite side. So now the law of sines, it makes life easy. Sine of 26 over 6.74. You guys are amazing at this. Equals sine of, oh, and now you ask yourself, does it matter which one I solve for? Angle A or B or angle C? And yes, it does. Okay, so this is the one critical part you really have to think through today. All right, so let me help you understand, because this is where people get this wrong on the test. Okay, we have to decide you're going to find angle B or C first. And this is what you got to think through. Is it possible for a triangle to have two obtuse angles? No. Every triangle at most can have one obtuse angle. Agreed? If this triangle has an obtuse angle, is it angle B or angle C?
C.
How come?
15 squared.
C has the longest side. So if we were to use the law of sines to try to come up with the possible obtuse angle using the law of sines, is sine positive or negative in the first quadrant? So it's positive for acute angles. Is it positive or negative in the second quadrant?
Positive.
Sine is positive in the second quadrant. So sine does not know the difference between acute or obtuse angles. This is how we started out this lesson. We said that sine was equal to 0.5 at 30 degrees and 150 degrees. Remember when we talked about the very beginning of this unit? So the fact is that if you press sine inverse of 0.5 on your calculator, is it grabbing the 30-degree angle or the 150? It's grabbing the 30. It doesn't know how to find obtuse angles. So if there's a possibility of C being obtuse, should we be trying to find it?
No.
Absolutely not. You must at this point find the smaller angle. So that's why the decision tree says that when you are solving for the missing side, start by finding the angle opposite the shorter of the two sides. So we go to our notes here and we say which one is shorter? Well, 12 is shorter than 15. So therefore I do sine of B divided by 12. So now it's set up. I can be confident that this will produce an acute angle. I know it's going to be acute. When somebody gets it, please share with me what it is.
Angle B.
Yep.
51.3 degrees.
51.3 degrees. Now, to find angle C, I don't have to use the law of sines. I can simply just subtract from 180. And when you subtract those other two from 180, what do you get? 72.7?
102.7.
Whoop. 102.7 degrees. Turns out it was obtuse. You would not have found that if you used the law of sines. Would not have worked. Okay? Good job. All right, last one. By the way, tomorrow I give you 5 minutes of instruction, and then you have the entire hour to work on your assignment tomorrow. You'll be able to get it done in class. And tomorrow, everything will come together if you're having any questions. It's a beautiful unit. It really is.
When's our test?
That I don't, trying to decide. I think I kind of got to look at the Winterfest schedule. You know what I mean?
Next week.
It's possible we might get at the end of next week.
Okay.
We'll see.
What you said for tomorrow, is that like a combined assignment?
So tomorrow what we're going to do is we are going to, so you have an assignment today, a law of cosines. Tomorrow you have 6 problems, and it could be any of the 6.
Okay.
And so it's just a day for you guys to practice and make sure that you know all about the 2 solution case and the 1 solutions and everything else in the no solutions. So, oops, sorry about that. Okay, so I'm going to, oh boy, come on, Kevin, get your crap together. There we go. The good news is that we've been keeping pretty good pace with this class. So if we have to take a day or 2 from time to time, I think that we're all right. Calculus class is in a rough spot. Well, they're doing okay. First semester, they're in a tough spot. They keep on having senior meetings during 6th hour, which is calculus. So I think there was a point we were 10 days behind of where we were last year. That's tough. It's hard. It's like, what do you do? Okay. 3 sides. Classify the triangle. Side, 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 right? So the question is, does it matter which one we find first? We go to the obtuse angle piece. Is it possible that there's an obtuse angle in this triangle?
Yes.
Yes. Which one would it be?
C.
It would be angle C. So if we use the law of cosines to try to solve this, let's think about this. Is cosine positive or negative in the first quadrant? Positive. So cosine is positive for acute angles. Is cosine positive or negative in the second quadrant? Negative. So does cosine know the difference between acute and obtuse?
Yes.
Absolutely. Cosine knows how to find obtuse angles. So we are going to use the law of cosines, and we are going to start by finding the biggest angle. And that's what it says if you look at your decision tree. It says side, side, side. There's one solution using the law of cosines. I crossed this next part off because I don't really like that I wrote it there. And it says just start by solving the angle opposite the largest side. That's where we live. And so that's what we're going to do. So I want to solve for angle C. So I'm going to set up the C squared formula. And the C squared formula will be 12.4 squared is equal to 10.5 squared plus 9.1 squared. Then what? Minus 2 times 10.5 times 9.1 times the cosine of angle C. Before you go too far in solving this, some people try to combine all this together. You can't do that. This is kind of like, say, an equation of 20 is equal to 14 plus 2 minus 3x. If you had 20 is equal to 14 plus 2 minus 3x, could you go 14 plus 2 is 16 minus 3 is 13? So I got 20 is 13x. Could I do that? Absolutely not, because those are not like terms, are they? So what you have to do is you would have to subtract that 14 over, you'd have to subtract that 2 over. In the same way, you're going to do that with this situation right now. So what I want you to do right now is take that 12.4 squared, and I want you to subtract 10.5 squared and subtract 9.1 squared. Do that first. Subtract those over. Somebody got a result?
Negative 39.3.
Good. Equals, now what you're going to have left is whatever negative 2 times 10.5 times 9.1 is. What's negative 2 times 10.5 times 9.1? Please be careful you keep track of the negatives in this problem. The negative matters. It's the difference between acute or obtuse when you're talking about cosine. So we get a negative 191.1. And then we attach cosine of C onto it. That's like our variable. So if we want to solve for angle C, what are we going to do to both sides? Yep, we divide by negative 191.1, divide by negative 191.1. And so you get 39.3 over 191.1 is equal to the cosine of C. So is our cosine value positive or negative? It's positive, so is this going to be acute or obtuse? It's going to be acute. Inverse cosine of 39.3 over 191.1. Inverse that, and then somebody please tell me what angle do you get for angle C? Remember, it started with a 7.
78.13.
78.13 degrees. That's the biggest angle in the triangle. So if that's the biggest angle, then that means A and B are both going to be acute. So we can use the law of sines with no worries at all. Let's use the law of sines. Sine of 78.13 over 12.4. I told you you're going to have to be good at the law of sines, and obviously you are. You want to use A or B? You tell me. A, sine of A divided by 10.5. We'll set that up. We'll do a simple cross multiplication and inverse our sign. And can somebody tell me what they got? I think it started with a 5. 50 what? 55.96 degrees. Can somebody else confirm that?
That's right.
Good. So I've got those two. Obviously the third one, they just add to 180 degrees. So for the third one, I can do, I think it's 46? 45.91 degrees. I check the reasonableness of my solution. Angle C and side C are the biggest. Angle B and side B are the smallest. Looks like I've done this correctly. Good job. You have more time than the other classes to get some work done. You've got about 14 minutes. I'll show you the problems you do not need to do. If you open your homework, the first two problems are going to say example 1 and example 2. You could cross off both example 1 and example 2.
I didn't see the example last week.
That leaves you with just problems 1, 2, 3, 4, 5, 6. Okay? A lot of people in previous hours got through problem 3 or 4. You do not need to find the area. Tomorrow, we will do simple instruction beginning class only about area. That's all we'll do. We'll show you the area, and then you'll be able to work right away.